A comparison between simple moving average and long short-term memory in stock prediction by Anay Shukla, and my mentor was Leif R. So a little bit about the background. So predicting future stock prices is quite complex, not only in its implementation, but also its principle. There are many factors involved in the implementation of the model that cannot be considered, such as the physical or psychological behavior of humans. However, the goal of this project will be able to test and compare two different machine learning techniques, specifically long short-term memory and simple moving average, and ascertain which technique is superior in predicting future stock prices over a configurable period of time. This project is fully done in Python. So the data set. The data that I have obtained was from NASDAQ's official website. The time series data included the open value, high value, low value, closed value, adjacent volume, and volume of the stock for the last 15 years that the stock has existed. After acquiring the data, it had to be prepared in such a way that there was only one input value. So I chose the closed value. The historical closed values are shown in this image. The next step is to pre-process the data. In order to do this, the data was split into a training set that had 950 points of data and a validation set that had roughly 350 points of data. Furthermore, the data had to be normalized so that it could be scaled correctly and avoid dominant patterns in stock behavior, which could potentially lead to bias. So the first technique that I implemented was simple moving average. It uses the latest set of values for each prediction. In other words, for each subsequent step, the predicted values are taken into consideration while removing the oldest observed value from the set. Here is a simple figure that will help you understand this a little bit better. The code that I've utilized is right here. So the results of the simple moving average. Simple moving average technique that was used in the scope of this project was fairly ineffective and it did not achieve accurate predictions within the validation data. The initial trend of the stock price, as seen in green in the image shown, is that the price went upward, which was predicted by the moving average technique as the blue line also went ever so slightly upward. After this initial trend was predicted, the green line flattened out as it could not get any more accurate predictions other than the first few days. This essentially shows that a simple moving average technique may be a good technique in terms of short-term stock price prediction. However, it may fail whenever it's used over a longer period of time. Another indicator of this accuracy or inaccuracy would be the RMSE value, which is the actual value minus the predicted value for each data point. In this case, the RMSE value for this technique was 105, which shows that the simple moving average technique didn't perform that well. The second technique that I used was long short-term memory. The same techniques were used to clean, pre-process, and normalize the data as mentioned before. However, in the implementation, an LSTM with 50 input neurons and one layer was implemented. The optimizer that I used for the LSTM was ADAM, or Adaptive Movement Estimation, which is essentially a gradient descent algorithm that updates the weightage of each neuron based on the training data. So here are the results of the long short-term memory technique. In comparison to simple moving average, it seems as if the LCM performed much better, to the point that it was practically perfect. However, there were quite a few major errors in its implementation. The best fit curve in the graph seemed to overfit to the extent where it was essentially the same as the validation data as seen in this image. In the implementation, it is apparent that the program is using the previous validation data to predict future prices, which results in a more inaccurate depiction of what long short-term memory is actually capable of doing. To add on to that, the RMSE value is extremely close to 0, which is practically not possible for a model that doesn't consider outside physiological factors. However, this is where we can see that the problem is overfitting. And so basically, in the second image, I fixed this overfitting, and we can see that it did ever so slightly better than simple moving average in its prediction. However, it was not substantial enough. So some further improvements that can be utilized in this project are first of all, there should be a ticker that updates the stock prices live, so there's more data in the model. For the LSTM model, more layers of STMs or creating stacked LSTM could be added, or using a dropout value to improve the generalization skills of the neural nets. Adding more epochs could also be helpful, as they would allow the model to perform better in more real-life situations. Throughout this project, it can be seen that using the closed values was also not enough to just predict it because of outside factors. Further improvements to get rid of this closed value would be using web scraping and sentimental analysis of articles that surround stock prediction, or using data from other companies that are related to the company at hand, specifically IBM, which is Red Hat, or just companies such as Red Hat, Google, and Microsoft. Thank you for your time, and thank you for listening to my presentation.